This is a short lesson about percent composition of compounds. Combustion analysis. Unknown organic compounds can be identified using combustion analysis apparatus. The sample is burned in excess oxygen so that all the carbon is converted to carbon dioxide and all the hydrogen to water. These two products can be separated and then massed. Another instrument, a mass spectrometer, can determine the molar mass of the compounds. The amount of carbon dioxide and water that are produced can be used to determine the percent carbon and hydrogen in the compound. The percent composition of a compound is the proportion of each element in the compound by mass. The sample may contain other elements also, such as nitrogen, sulfur, and oxygen. So to figure out the percent for the element, you take the mass of the element and you divide it by the mass of the compound and you multiply it by 100%. Now, the units on the masses don't matter as long as they are the same. So if you've got milligrams, samples, everything has to be in milligrams. If you've got grams or kilograms, doesn't matter as long as all of the units in the question are the same. So let's do an example. 500 milligrams sample of aspirin contains 300 milligrams of carbon, 8.08 milligrams of hydrogen. The remaining mass is oxygen. Determine the percent composition of aspirin. So we have three elements. We have carbon, hydrogen, and oxygen. So we've got 300 milligrams of carbon, and the entire sample is 500 milligrams. So milligrams are going to cancel, and what you have is the percent carbon in your sample. So 300 divided by 500 times 100%. So this is 60.00% carbon. Hydrogen, this is 8.08 milligrams of hydrogen divided by 500 milligram sample. Times 100%, and we get 1.616% or 1.62%. Now to figure out oxygen, we need to figure out the mass that is oxygen. So we know 300 is carbon, 8.08 is hydrogen. So you add these together and subtract them from 500 and you've got the milligrams that is just oxygen. So that's 191.92 milligrams that is oxygen. So 191.92 milligrams of oxygen per 500 milligrams of sample equals 38.38%. That is oxygen. That's hydrogen. So our sample contains 60% carbon, 1.62% hydrogen, and 38.38% oxygen. When you round off your numbers, you're going to find that sometimes these numbers are a little bit off of adding up to 100%. If they're off by a few 100ths or maybe one decimal place, don't worry about it. Okay, example number 2. Researchers found a compound containing nitrogen and oxygen. You have a 4.60 sample containing 1.40 grams of nitrogen. What's the percent composition? So we have a sample that's 4.6. We've got 1.40 grams, that is nitrogen, and the whole sample is 4.60 grams. Multiply that by 100% and you've got the percent that's nitrogen. Thanks, Ava. This percent is 30.4% nitrogen. Now, there's two ways you can figure out the oxygen. You can subtract 1.4 from 4.6 to figure out the grams of oxygen, and then divide that by the grams of your sample and multiply by 100%. Or we know there's only two elements. We know percent nitrogen plus percent oxygen equals 100%. So if we know this quantity, we can solve for this one. So the percent oxygen is equal to 100% minus the percent that is nitrogen. So 100 minus 30.4 is 69.6% oxygen. Sometimes you're not given grams, but you're asked to find the percent composition of a compound. And you can do this by using the chemical formula and the number of atoms of each element in the compound and the mass of those elements in the compound. Now, you could use grams per mole, you could use molar mass, or you can use atomic mass units. You'll get the same percent. Just make sure you're consistent with your units. Okay, so let's say we want to know the percent composition in calcium hydroxide. So we want to figure out the percent calcium, the percent oxygen, and the percent hydrogen. So there's one atom of calcium in calcium hydroxide. So it's going to be 1 times the mass of an atom, or the mass of the element, is 40.08. I'm going to use molar mass, but you could use atomic mass units. And then you put this over the molar mass of the entire compound, or the atomic mass units for the entire compound. So oxygen. How many oxygens are there in calcium hydroxide? There's 2. 2 times 1. So 2 times the molar mass of oxygen divided by the molar mass of the entire compound. And the same thing for hydrogen. There's 2 hydrogens. The molar mass is 1.01. So we have to divide each of these by the molar mass of the entire compound and multiply by 100%. So if you're using atomic mass units, it would be atomic mass units replaced where we have grams per mole. Oops, times 100%. Okay, so grams per mole would cancel. Your units always cancel. And you can figure out the percent composition now of each element. So it is 54.09% calcium, 43.18% oxygen, and 2.73% hydrogen. So these should add up to 100%, give or take, because I've rounded these numbers down. So 2.73 plus 43.18 plus 54.09. And this is equal to 100%. It's always good to double check, just in case you've made an error somewhere. So calcium hydroxide is 54.09% calcium by mass, 43.18% oxygen by mass, and 2.73% hydrogen by mass. That's how you figure out percent composition of your compounds.